All right, guys, this is my third time trying it. If I flub over my words, you guys are going to just have to deal because I don't want to start over again. I'm on the way to soccer. My kids are in the car.
Yeah, we are. Hello.
My husband's driving, and he's not going to say hi. Okay, so basically, I'm going to just quick sum up the story. The story is about people who are in an experiment about cholesterol level drug. Their hope is they want to have a higher increase in the reduction of their cholesterol levels after the medicine. Sweetie, this is a microphone. Okay. So, Group A has a placebo. Group B does not have a placebo. You can take the time to read this on your own if you need more context to it. But basically what they're hoping for is that this Group B has a higher reduction in the cholesterol levels after taking the drug. They want a big reduction to know that that drug actually works. They compare it to the placebo, and the reason they compare it to the placebo is because we want to control the placebo effect. So let me quickly talk about that. We have Group 1, we have Group 2. If we find Group 2 wins and the medication actually helps, and Group 1 never got a placebo, then we have a lurking variable. Did the medicine actually help, or did the patients actually just feel better because they were taking a pill? This is the placebo effect when Group 1 does not have a medication. Now, I like to call it the Band-Aid effect. My daughter, Annika, say hi, Annika.
Hi.
She falls down, scrapes her knee, doesn't need a Band-Aid, but asks for a Band-Aid. Why? She instantly feels better once she gets her Band-Aid. We need to control this as statisticians. So what do? We give everyone some medicine. Group 1, they get a placebo pill, a sugar pill. Group 2, they get the actual medication. And now we don't have to worry about this lurking variable anymore. Review on placebo. Let's go back to the actual significance test. The question is stating, did the data provide convincing evidence at alpha equals 0.01 that the cholesterol level is effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet? Now, I said I'd keep this to under 10 minutes, and I'm doing my best here. Again, I'm talking fast, but I'm not teaching this to you for the first time. We've learned this several times, so it's just a quick review. In the states, sorry, give me a second. We need to state three things. We need to state what the mu's are, our null hypothesis, and our alternative hypotheses. Mu1 equals the true mean, and it should say cholesterol reduction in people like the ones in the study who were in Group A. Why do I say the ones like the ones in the study? Because it's an experiment. Mu2, the true mean, it should say cholesterol reduction in people like the ones in the study who were in Group B. Our null hypothesis, we always assume that they're the same. Mu1 equals Mu2. Our alternative hypothesis is that Mu1 is less than Mu2. Why do we want Mu1 less than Mu2? Because we want Mu2, the second group, the one with the cholesterol drug right there, Group B, we want that to have a higher reduction level. Moving on to the plan. Remember with the plan, you need to check for both samples when you're doing a 2-sample. Random sample of 20 middle-aged men from a hospital, and they were randomly assigned to a group. As a result, both groups are independent of each other, as well as their individual responses are independent of each other. Next, the normal model. 10 is greater than or equal to 30 for a group A, and 10 is greater than or equal to 30 for group B. Well, that is not correct. So what do I have to do? Remember, the t-distribution, the t-test is robust. That means it will still work as long as I go up and graph it with the dot plots. I'm going to pause it real quick because we're here. I'm going to have my son and husband get out of the car. And my daughter will stay with me, and I'll quick finish it. Okay, so we're back, you guys, and you can see here we have our dot plot that we plotted, and we have our dot plot for Group A, and then we have our dot plot for Group B. This is awkward filming myself, but my kids really wanted it, so bear with us. Okay, so when I'm doing this, I look at my dot plot, and especially Group A, that looks pretty symmetric. There's no strong skew, and there doesn't appear to be any outliers. In the red distribution down here, it looks not as symmetric. There's a gap that I'm not super comfortable with. But the key here is don't stop. You keep going. And the reason that is, you could say a statement like, if you were uncomfortable, you could say, there's kind of a big gap. So proceed with caution. How do you know when to stop and not proceed on the AP exam? They will prompt you. They will say, just check the conditions, which one doesn't match or which one doesn't fit. Okay, so we're going to keep going. We're going to move on to the method. Remember, for the method, you need to think, what am I dealing with? A Z or a T? We're dealing with a T because we're dealing with the means. Next, you say, what is it, 1 sample or 2 sample? They gave us 2 samples. So we look and we say, hey, we have a 2 sample t-test for mu1 minus mu2 with no and this is not in the right spot. For group, that's describing the dot plots. Sorry. Okay. And now we're at the do part. And I'm going to draw my curve. But before I draw my curve, I'm going to go into my calculator and I'm going to go to stats and I'm going to go over to tests and I'm going to go to 2 sample t-test, which is number 4. Now they give you a list of data, right? So if I scroll up here, I can see I could put all of this in L1 and all of this in L2. But remember, the AP world doesn't want you to be a number cruncher. They want you to be a statistician, an interpreter. I have the statistics right here, this X bar of A, SX of A, X bar of B, SX of B. So I can type those statistics right into my calculator. So I'm going to do that now. I'm going to scroll down and make sure I have the right alternative hypotheses checked. I never do pooled. Pools is for proportion, and I'm going to calculate. And I already dragged that screen over, but I just wanted to go with you how to type everything in. And you can see that screen right here. I'm going to write everything down, and then I'm going to start filling things in. So in my curve, you can see the curve. In the center, we always have the mu. The standard deviation, I'm going to get through my formula sheet or I have it memorized, but they will have it on there for you. Forgive me, I'm not sure why I put the square root of 10 over it. It should just be 10. Okay. Whoops. But you guys get the point, right? And then we get our t-score. I take my observation times minus my mean, divided by my standard deviation, and that gives me negative 1.617, which comes from my calculator as well. Where did I get that negative 6.2? I had to calculate that. You can just put x bar of 1 minus x bar of 2 there if you want. So you could just put 10.2 minus 16.4 and then transfer that down here. In parentheses, minus 0. But I just did it in my head real quick because it's easy to. I write down my p-value, 0.062, and then I conclude. Because our p-value is approximately 0.062, which is greater than alpha of 0.05, we fail to reject the null hypothesis. We have no evidence that the cholesterol drug is effective in producing a mean reduction in cholesterol levels beyond that produced by exercise and diet. How did I get that context? I just went up to what was the actual question, and I let that question help me with my context. Again, I'm going super fast, but I'm going to use my last minute to quickly talk about the difference between a 2-sample t-test and a 2-sample t-interval. Okay. I used the same data, and technically that's incorrect because this is a one-sided test. This statement should have said, does their data provide convincing evidence of a difference? How does it change if there's an interval? Okay, an interval is always with a two-sided test. You can never do it with a one-sided test. I just want to show you some basic changes, though, just using this data. So in the state, you only have to state the parameters. There's no alternative or null hypotheses. Don't do it because I'm afraid you'll do it wrong. Remember, it's always a two-tail just in case, but again, I don't want you to do it incorrectly. The plan stays the exact same. You have to talk about, for group B, the dot plots are symmetric enough, and you have to talk about group A. I don't know why I didn't put group A. I should put group A and B. The dot plots are symmetric enough with no apparent outliers. If you want to say you're a little uncomfortable, just say I proceed with caution. Remember, you do have to talk about both groups. Oh, okay, here's my do. 2-sample t-interval. I take my x bar of 1 minus my x bar of 2 plus my t star. Now, I do need to write down here for degrees of freedom of 17.29 because that's not in my chart. I get my interval straight up from the calculator,